Welcome to CS284 Module 3. I'm your instructor, Robert McMillen, and we're going to talk about application and network attacks. These are a little bit more sophisticated types of attacks that are out there. And we'll talk first about web application attacks, cross-site scripting, SQL injection, directory traversal, drive-by downloads, session hijacks, tracking cookies, and header manipulation. So let's start with cross-site scripting. So this is editing of websites to inject web code. JavaScript is an example to do something that is unintended. Embedded script tags in pages on one site calling code hosted on another site. Commonly used on sites with GET forms that put user-generated data into a URL. And poor sanitation of user data. So let's talk about what that means. So embedded script tags in page on one site calling code hosted on another site. There's a lot of different websites that you go to that don't just show data from their own website. They also show ads and various different things from Google, DoubleClick, and all these other places that basically they embed these script tags from other sites. Well, if their security is not set up correctly, you can embed your own script tags, exploiting holes in JavaScript that will call from a site that you set up that may be a hack site in order to get people to click on those links and put information in there that you can then use to steal their identity. The commonly used on sites with GET forms that put user-generated data into URL. There's a lot of different forms out there that you put information into, and if those websites are not properly secured, then they can have this kind of thing happen to them. Poor sanitation of user data, that happens when a user is done with their session and they're supposedly logged out, or maybe they ended their session before logging out. The website should scrub that information so it can't be used by anybody else. So if they don't have that kind of sanitation being used, then hackers can put in information that can actually grab that information off that website. An example, this where it says XSS, that's cross-site scripting, like we just talked about, would be if you go to a website and there's a search box and you type in user text, and in the results you end up seeing a whole bunch of different user sessions, and all of their usernames and passwords may pop up. Another type of thing would be you type in the word JavaScript, and the results for JavaScript show up, as well as the embedded script. So this should be hidden information, but instead the search is searching everything, and it shouldn't be showing the hidden information, but it does. And it also should have been scrubbing that information, but it didn't. So this happens a lot of times because of poor programming and unpatched servers. Slightly more advanced types of cross-site scripting hacks would be using forums to store embedded cross-site scripting code, using iframes to load in another site. So if you load in this other site, as we talked about earlier, then you can get people to click on those and then end up getting infected or having data stolen. Also, drive-by downloads in sites or in emails. And these types of downloads can also infect your computer and cause your information to be compromised. Hide script commands as other HTML tags, so you can hide these scripts inside what looks like a plain, simple link to another website. And when you click on them, these scripts end up running and causing all kinds of damage. You can code as hex, ASCII, or other obfuscation, and so basically it doesn't look like anything bad. People don't understand what it is they're looking at, and therefore they click on it not realizing that it's actually going to cause damage. SQL injection has been around for many years, but it still seems to work because administrators are not properly securing their SQL servers. So many times you have a web form, and on the front end, and people type in their data, and on the back end there's a SQL server that holds all that information, such as a shopping site, that kind of thing. So the form uses raw data, raw user input as part of SQL. So if they're not properly filtering that data, then anything you type into those web forms could also be interpreted by the SQL Server as a command. Insert SQL commands into these web forms, and again, poor sanitization of user data also makes that data available. Once the hacker has access to that database, they can expose information, maybe put everybody's social security numbers on a website. They can alter it to make it unusable, or they can even destroy it. Directory traversal. What could that mean to a computer? Well, sometimes pages that should be hidden or directories that should be hidden are not. And if you just type in the right path, or you guess the right path, then you can actually see those folders and what's inside them. So it reveals more data than should be public. Typically, this kind of thing would expose the company more than it would expose users, but that's also a possibility as well. And it allows access to known executables. And from there, you can either upload executables if the permissions are set incorrectly, or you can run the executables and then have access to data that's on the inside of that database. Session hijacking uses cross-site scripting to grab session IDs for sites that use session IDs as part of the URL. So you can actually look at a URL when you're logged in and you can see session IDs. Well, if you know what your ID is, you could probably deduce what other people's IDs are, and then you can start a login session as the other user. Network sniffers grab session cookies. So authenticated encrypted cookies are sent as a token, so that way it passes just fine through the security of the web browser. But then the rest of the communication session is unencrypted. And a hacker can start their own session using the same validated cookie and use header manipulation. So that way a user can be compromised just by surfing a website. Header manipulation uses hidden data that's sent with every web request. It's auto-generated by a browser, user agent, language, refer, etc., that kind of thing. These are things that are automatically sent anytime a browser communicates with a website, such as if in language, for instance, if you are going in under the English language, that is hidden information that's sent through the browser. Well, you can also send other hidden information that should just be automated information that's innocuous. Well, you can also make it so it's used as an attack. And of course, the web user doesn't realize that it's happening, and many times the administrator of the website doesn't realize it's happening either because their server may be unpatched. Software to manually add or edit common data, manually craft packets, use a proxy, or use a Firefox plugin. So many different plugins that are in Firefox. It tends to be an open source community. A lot of these plugins, if you trust them, could also be something that a hacker has made and maybe tried to pass off as a legitimate plugin. There's all types of plugins, and you can go into Firefox under the options and see what plugins are running, and you can go and disable them and make it so no plugins work if you want, or just enable the ones that you want to work. Network attacks, there's denial of service, man in the middle, and switch bypass. Denial of service basically makes it so a whole bunch of computers all attack a computer using ICMP pings or other large amounts of data, and it just causes the website that they're attacking to no longer have any bandwidth in order to continue running. Man in the middle is a type of attack where someone intercepts traffic, and there's various ways to do that. The easiest way, of course, is to do it through wireless communications, but it can be done through wired as well. Once that information has been grabbed, you can then take that information and use various different tools in order to read that information in plain English, and a lot of times that could be usernames and passwords. And there's also switch bypass, which we'll talk about in a second. So the denial of service overwhelms the network resource, so it cannot provide the intended service. You've got ping floods, reverse floods, connection floods, basically just sending a lot of data all at once to a system, so it just can't operate. Man in the middle, as I mentioned, is where you're eavesdropping on network communications. You can then poison the DNS or the ARP cache. Remember, DNS is forward lookups, ARPs, reverse lookups. So this is names to IP. This is IP back to names. And you can poison that information so that way you can send them to websites that look like the websites they're trying to go to. So for instance, you're going to bankofamerica.com. When you go to your DNS server, it says, hey, bankofamerica.com is at this particular IP address, where you would put in your username and password. If you poison that DNS, then when you try to go to bankofamerica.com, it will send you to the hacker's website, where they'll have a duplicate Bank of America that looks just like the one, and you'll go ahead and use your username and password because it looks just as you expected it to look. Switch bypass uses an ARP flood. ARP flood is switched to overflow a CAM table. So when a switch, which has a certain amount of memory into it, becomes overwhelmed, then that switch becomes a hub. A hub basically uses broadcast traffic instead of MAC addresses to find information. And although a switch by default does not broadcast, it will if it runs out of memory and if it's unpatched. Well, once it starts broadcasting information about places it's trying to find, it can then broadcast information to the hacker, so they will be able to deduce what IP addresses are valid on the inside of a network and then go and attack them. So we've learned a lot from application and network attacks, and there is an assignment, of course, that goes with that. So take a look at Chapter 3, and if you have any questions, feel free to let me know, and good luck on your assignment.